So welcome back to episode 42. Today we're going to talk about avoiding null checks altogether. And the way that we're going to do that is with a type we've already seen, but I want to hopefully try to give some examples of, why you might use some of these things or patterns that you might see in the wild if you're programming imperatively that could be resolved if you move to more of a functional approach. So where are we going to start? The first thing, let's do an upper function here. Given an x, we call x to uppercase, and of course if we pass foo, then everything's great. And of course if we pass undefined to this, then it obviously blows up. This is, cannot read property of undefined, which there's no small shortage of memes related to that thing. So obviously that tells me that this is a pattern or an issue that people are having with JavaScript, and not just JavaScript, but any language where undefined is a concept. And so what I want to talk to you today a little bit about is just to make sure that we can see how to remove that issue altogether. So let's comment that out, because as it turns out, the errors that throws just blows up everything that we've got in here, which kind of further, I guess, illustrates the point of why undefined is an issue. So what could we do about this? Well, we could be a good developer. We could create a new function that, what do? Well, we check to make sure that x is good. And if x is good, then we call x to uppercase, else we pass undefined. And that allows us now, we can pass undefined. See, we just pass undefined straight on through. If you've done any C#, this is basically what the question mark operator does for you. You don't actually resolve the issue. You don't fix anything. You just play hot potato with it and pass it on to someone else. It's like undefined wasn't my problem. I took care of it in my code. I was diligent. I'm a real developer, which is a load of rubbish, right? Let's fix the thing once and for all. Obviously, this does work if we pass foo. But what I want to talk to you today about is using maybe for this. It might be the one that the type that you need for this. There are several types that would all work for this. But if we were to use maybe, and we were to have a new function called, we'll call it g, and it accepts an x, and if we use this built-in maybe.toMaybe here, that's going to do our null coalescing check, very similar to what we had here. But what it's going to do is it's going to take that x, and if x is truthy, it's going to return a just of whatever that value is. And if it's not truthy, then it will return a nothing. Both of those are somethings, though, right? Because either way we go about this, we're not returning this undefined, which is some special value that absolutely everything in the language can be, which is where the problem is, which is why you see it so much in this language, and in a lot of languages that have, whether it's undefined or null or whatever, right? It's the same concept. So we can call maybe to maybe. Well, but we still want to do the uppercase. Well, and this is where, if you saw any of the other videos about functors or whatever, we have map. You can map over a maybe. And because we can map over a maybe, we can insulate ourselves against this thing being a falsy value coming in by calling maybe to maybe. And then we can still map, and we can call the upper function. Now what's interesting is this upper function is exactly the one that I defined up here. It's unchanged. This function wasn't the problem. It was the fact that we can't depend upon values coming into this to always be truthy values. Or for, better said, for x to not be null or undefined. And so when we do it this way, now we can call g and we can pass foo to it, and we get a just of foo. Well, just is one of the options for maybe. One of the types that maybe can be. And the other one is nothing, and we already kind of mentioned that. But what's interesting is now I can call this same g function pass undefined, and what happens? I return back a nothing. That's fine. There's absolutely no problem with that, because I could still then continue calling stuff on this, x dot length or whatever. Doesn't really matter. We still get a nothing. So we've solved this. anyone who calls this function now realizes that they're going to have to deal with the fact that the thing that's returned is this maybe thing, right? Which seems like you're being a bad steward of code, but in actuality, what you're doing is you're letting them know that you're going to have to deal with this because there's some things that I just simply can't handle. I would much rather call into code and work with libraries that do this sort of thing than ones that try to sweep it under the rug and push the onus back on you to be diligent again. This doesn't require diligence. There's no diligence here because basically if I don't deal with the fact that it's returning a maybe, I can't deal with the thing that's returned, period. So there's no diligence that's involved. If you're dealing with code that is written this way, then you have to have diligence because the person who wrote this function cared about what they needed to do and we're just going to pass on whatever else was passed in, assuming it was some sort of an undefined. So there you have it. Avoiding null checks. We're using maybe in this case, but there are several other types that you could easily do that with. Either is an obvious one that would work for that as well. But hopefully you see kind of how this is used and why we're quote unquote adding complexity or constraining a type system, stretching a type system as I've been told I do with this. Hopefully you see why we're doing that. In my opinion, it's going to solve most of the problems that you've got with null checks, or if you're writing this sort of code a lot, or this sort of code, I guess, as well. So there you have it. Let me know what you think. I hope you enjoyed it, and I'll chat with you tomorrow.